Have you ever thought that something was broken and then picked it up or touched it and realized that it was actually fine? Well, today we're going to do a fun experiment. I have some lab utensils here. I have a clear glass bowl, a measuring cup with some water, a pen, and a pencil. Now, something really interesting is going to happen when I pour the water into the bowl and then take the pen or the pencil and put it into the water. Can you guess what the pencil is going to look like, or the pen, when I put it into the water? What's going to happen to it? Will it bend? Will it be normal? Or will it break? Well, let's find out. I have my bowl here, and I have my water. I'm going to take the water and pour it into the bowl. Then I'm going to take my pencil and put it into the water, and let's see what happens. Whoa, that's really weird. My pencil looks like it's broken. I wonder what's going on. Let's see. Let's see what happens if I take it out. Is it broken? No, it's not. It's not broken. I'm gonna put it in again. That's really weird. Let's try something else. Maybe it's just this pencil. I'm gonna try the pen. That's weird. The pen also looks broken, but it's fine. What is going on here? I wonder what it is. Can you guess what it is? Pause the video, think a little bit, and then give me a guess as to what is going on and why the pencil looks broken when I put it in the water, but when I take it out, it looks perfectly fine. Pause the video and take a guess. So why does this happen? Well, light helps us see. And when we look at something, what we're seeing is the light bouncing off of whatever we're looking at and coming to our eyes, right? This is how we see something. Light travels differently in air than it does in water. So imagine this. Imagine you're running on the sidewalk and then you run into some mud. What happens? You probably slow down a little bit, right? Because you're running through mud. And then maybe your feet kind of like slip and slide a little bit and change direction and stuff. Same thing happens to light. When light travels through air, it travels really fast. Light travels in a straight line in the air. But in water, light has to slow down and it bends a little bit, changes direction in the water like you do in the mud. It cannot move the same way in the water as it does in the air because it's two different materials. So what happens is light behaves differently in the water than it does in the air. But your eyes don't know that, right? So when the light bounces off the pencil that's in the air and goes to your eyes, it goes straight to your eyes. And the pencil looks normal. But when the light bounces off the pencil that's in the water, it bounces off differently. It bends as it moves into the air. But your eyes, again, it doesn't know that the light has bent. And so it thinks that the pencil is in a different place than it really is. And so the pencil looks like it's broken. And if you take the pencil out of the water, then the light doesn't bend anymore. So it looks normal, looks straight. And when you put it fully in the water, then the pencil looks normal again, it looks straight. But when you put it halfway in the water and halfway out of the water, because the light hits the two different parts of the pencil differently, then the two different parts of the pencil look different. Because each part of the pencil and the light are behaving differently, then both parts of the pencil look different, and it makes it look like it's broken. One way that this happens in real life is if you're swimming. You know when you get into the pool and then you look down into the water and you can see your legs and they look really short, but they're not actually short, they didn't shrink. It's just that through the water, your legs look different and the light is hitting your legs differently than it's hitting your body. And so it just makes it look short. It's not actually shorter. This also happens with other things, like if you were to get a glass of water, not just a pencil or a pen would look different in the water. Other things would too. If you took a ruler, or if you took a spoon, or if you took even, a Hot Wheel car and you put it in, and half of it was out and the other half was in the water, then it would still look broken. So my challenge for you now is to do the same experiment and get a bowl and fill it with water, and then take different objects from around the house and put it into the water, and then ask your family why they think the objects look broken when they're in the water. So there you go. That's how light works and how it behaves differently in water and air, and why it made it look like the pencil was broken. Teachers use discrepant events to encourage cognitive disequilibration. This is because discrepant events are scientific concepts where the outcome directly challenges the existing expectations of how natural laws should work in this world. In this lab experiment, the pencil appeared to have been broken, but it really wasn't. Based on how the pencil looked in the water, it should have been broken, but it wasn't. It was a discrepant event. This makes us think, makes us ask questions and explore, and ultimately learn about a new scientific concept or scientific law. So discrepant events can be used in an introduction to a grade level GSE standard by using it as a hook. You use it to get the students' attention, right? It gets their attention because it's so different than what they expect. It causes them to question their assumptions. It makes them, interested in the lesson. It promotes critical thinking, engagement, constructivism, the idea of constructivism, and incorporates hands-on and minds-on learning. Thank you.